Welcome to Learn English at Home 79, where we slow down and dig deep into real stories. Let me open with a question. Would you believe there's a country intentionally breeding millions of mosquitoes? Sounds upside down, right? Most people want to crush, zap, or spray these tiny pests into extinction. So why would a government invest in making more of them? Today, we're unpacking a surprising story from Singaporean where science turns an enemy into an unlikely hero. Ready for the journey? Let's find out what's really buzzing behind this counterintuitive plan. Now you might be thinking, isn't this just inviting disaster? But the answer, as we'll see, reveals a high-stakes battle against one of the deadliest animals on Earth. Stay tuned as we set the stage for the mosquito paradox. We'll look at the facts, follow the science, and by the end, you'll see why millions of extra mosquitoes might actually save lives. So sit back, relax, and prepare to have your expectations flipped by one of the most inventive public health moves in recent history. Let's get started with the tiny enemy at the center of it all. Let's zoom in on the real culprit, the mosquito. These insects may only weigh a few milligrams, but they pack a punch-transmitting diseases like dengue fever to millions each year. Dengue, or dengue as it's sometimes pronounced, isn't just a bad fever. It's a viral infection with symptoms like severe headache, high fever, joint pain, and sometimes even hemorrhagic complications. That's when blood vessels get leaky, a medical emergency. To put the threat into perspective, the World Health Organization reports that dengue infects 390 million people annually. That's more than the entire population of the United States. Imagine a city where every bite could make you dangerously ill. In Singapore, the Aedes aegypti mosquito is the top suspect. It thrives in urban environments, needing just a bottle cap's worth of water to breed. It's like the ultimate survivor, perfectly adapted to human habitats. The conflict is clear. A tiny insect, a massive threat. And when the rains come, or people stay indoors, the mosquitoes' breeding grounds only multiply. The stakes? Public health and lives themselves. Let's zero in on Singapore. This city-state is famous for its cleanliness and order, yet it faces a relentless battle with dengue fever. Why? Because the dense population and tropical climate create a perfect breeding ground for Aedes mosquitoes. Last year alone, Singapore logged over 26 dengue cases, one of its highest tallies ever. That's not just a statistic. Each case means a sick person, a worried family, and a stretched healthcare system. You might be thinking, isn't Singapore advanced enough to control bugs? The answer is yes and no. The government's rapid response teams and public campaigns are world-class, but mosquitoes are relentless, exploiting every puddle and drain. The result? Dengue outbreaks surge after heavy rains, and urbanization gives mosquitoes plenty of hiding spots. It's a classic case of vector adaptation. That's when a disease carrier like the mosquito evolves alongside its environment. Singapore's fight against dengue is a race against a foe that can multiply overnight. The situation cries out for a breakthrough one beyond traditional methods. So, how have people tried to fight mosquitoes in the past? Let's start with pesticides. These chemical agents, like pyrethroids, were once the frontline defense sprayed in homes, fogged in streets, and used in water tanks. For a while, it worked. Populations dropped, and dengue cases fell. But then came a twist: resistance. Over generations, mosquitoes developed genetic mutations that let them survive chemical attacks. Think of it as mosquitoes wearing armor against our best weapons. Another classic method, source reduction. That's public health speak for eliminating standing water flower pots, gutters, even bottle caps. It's simple, but in practice, nearly impossible to find every potential breeding site. Natural predators, like guppyfish, have also been used to eat mosquito larvae in water. But with over 500 mosquito species and urban environments, there's only so much these allies can do. The conflict? Our old tools are losing their edge. Mosquitoes adapt, cities grow, and dengue keeps coming back. Clearly, the solution needs a new twist, something smarter, more sustainable. Here's where science steps in with a plot twist. Wolbachia. This is a genus of naturally occurring bacteria that, when introduced into certain mosquitoes, changes everything. Wolbachia acts like a microscopic gatekeeper. When it's inside an Aedes mosquito, it blocks the dengue virus from reproducing inside the insect. In simple terms, it's like giving mosquitoes a virus-proof vest they can bite, but can't pass on dengue. You might ask, doesn't bacteria usually make things worse? In this case, Wolbachia is a symbiont. It lives inside insects harmlessly and actually helps us by stopping disease transmission. Wolbachia can also be passed from female mosquitoes to their offspring, helping it spread through wild populations over time. But Singapore's approach takes this a step further, focusing on males. Why? Let's find out. It's a classic Act 2 conflict, using a tiny ally to fight an even tinier enemy. The resolution? A new biocontrol strategy that could outsmart dengue at its own game. Singapore's scientists made a crucial decision. Release only male Aedes mosquitoes infected with Wolbachia. Remember, it's the females that bite and spread disease. Males just buzzmate and move on. Here's the technical magic. When a Wolbachia-infected male mates with a wild female, the eggs laid by that female won't hatch. This is called cytoplasmic incompatibility, a biological dead end for new mosquitoes. Now you might be thinking, so more mosquitoes but fewer babies? Exactly. The released males don't spread dengue, and every time they mate, they cut off the next generation before it starts. This isn't about killing mosquitoes outright. It's about suppressing their population from the inside, using their own biology against them. Think of it as a Trojan horse strategy, nature's own population control. The setup: millions of males, no bites, no baby mosquitoes. The conflict: can we outnumber the wild males? The resolution: steady, targeted releases that tilt the population in our favor. Let's take you behind the scenes of Singapore's Mosquito Factoria high-tech facility, not for robots or gadgets, but for breeding and sorting mosquitoes by the millions. Here, technicians start with eggs, nurture them through larva and pupa stages, and then identify the newly emerged adults. The technical term for this process is mass rearing, and it's all about skeletons of thousands of mosquitoes per day, every day. Now, separating males from females isn't easy. They use size differences and sometimes even machine learning algorithms to automate the sorting. Imagine conveyor belts and tiny sensors checking each insect's size like airport security for bugs. Sorted males are packed into special containers and strategically released across neighborhoods using vehicles and even drones. It's a logistical ballet with timing and location critical to success. The Act 3 resolution? A seamless pipeline from lab to sky, ensuring a constant supply of Wolbachia warriors in Singapore's urban battleground. Once the release is started, everyone asked, does it actually work? Singaporean scientists didn't just hope, they measured. Using ovitraps, which are special devices for catching mosquito eggs, they tracked Aedes populations weekly. Within a year, some test areas saw mosquito numbers plunge by over 90%. That's not just a blip, it's a population crash, the kind that interrupts the chain of disease transmission. Public health data soon followed. Dengue cases dropped sharply where Wolbachia males were released, leaving fewer people sick and fewer hospital beds filled. You might ask, is this just a temporary dip? The answer: as long as releases continue, suppression holds. It's like constantly lowering the water level in a bathtub. You can't just turn off the tap and walk away. The resolution is clear: science, measurement, and persistence combine to turn theory into real-world results, giving hope to cities everywhere. With such success, why not declare victory? The truth is, the fight isn't over. Sustained impact depends on continuous release. Male mosquitoes only live about a week, so the factory never sleeps. Another challenge: specificity. The Wolbachia strategy mainly targets Aedes aegypti, the main dengue vector. But there are thousands of mosquito species, each with its quirks. You might be wondering, could this work globally? The science is promising, but local differences in climate, urban design, and mosquito behavior mean each rollout needs customization. There's also the issue of public perception. Some residents worry about more mosquitoes, not fewer. Communication and transparency are essential. Explaining the science and showing the data builds trust. The Act 3 resolution? Continuous innovation, community engagement, and scaling up without losing sight of local needs. Singapore's success has rippled worldwide. Other countries, from Australia to Brazil, are piloting Wolbachia-based mosquito control. The technical term here is biocontrol scaling, adapting a local success to global challenges. There's even talk of using similar strategies for other pests, think Zika, chikungunya, or yellow fever. The broader vision? Harnessing microbiology to turn disease carriers into disease blockers. Now you might ask, is this the beginning of the end for mosquito-borne diseases? Not quite yet, but it's a giant leap. Science is showing us that sometimes the best way to fight nature is with nature itself. Let me leave you with this. The battle against mosquitoes is a marathon, not a sprint. But with smart science, creative thinking, and persistence, we're rewriting the rules and maybe, just maybe, outsmarting one of nature's deadliest foes. Thanks for listening. If you enjoyed this story, let us know, and remember, the tiniest solutions often have the biggest impact. Until next time, stay curious and stay safe.